heed it when I warned you last time. You need to heed it now. You got to be careful. There's a lot of terminology. A lot of terminology. I don't think anything's extremely hard, but you got to remember it. And you're not going to remember it without reviewing it. You're just not. It's a lot of stuff. All right. 12.3, polygons. Polygons. All right. Polly wants a cracker. All right, that would be something else. Here we go. Polygons. Number one, a polygon is a, first word in blue, simple. That was a loud hiccup there, John. I know. And not only is it going to be simple, it's going to be closed. A polygon is a simple closed curve made up of line segments. Now, I see 3 blanks I could ask you easily on that question, maybe even 4. I could use the word curve, or I could put the blank at polygon, use the word polygon, right? A lot of different short answer questions I could ask you out of that. But you got to know definition of a polygon. Simple closed curve. All right, so what does that mean? All right, what in the world does that mean? Let me try to help you. First off, simple. Yeah, simple's not too hard. Simple means the segments don't intersect. The segments don't cross each other. All right, they don't cross. So we'll draw some simplistic polygons. All right, you ready? Yours don't have to be exactly like mine. Here, I'm going to go zip, 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 and zip. Yours doesn't have to look exactly like that. As long as no line segments cross each other and it's not opened up. That is a simple closed curve. Here I'll do a simple curve. This is for all you Georgia Bulldog fans, if there are any out there. Zip, 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 zip. Okay. That is a simple curve. Nothing intersects itself, does it? Right? No segments are crossing, are they? And that's what simple means. Here's a knot. So I'm going to go zip, 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 zip. And then I'm going to take my red and say that is not simple, right? You see how those cross? Again, anything with the appearance of crossing, it crosses. So simple, nothing intersects. The second word is closed. So in green, closed. What is closed? It means the curve is continuous. C-O-N-T-I-N-O-U-S. It's continuous. If you think of it, it has no beginning and no end. No beginning and no end. Like God, right? God is infinite. He's the I am. There is no beginning. There is no end. And a simple or a closed curve has no beginning or no end. So if you look back at the simple ones, don't do this in your notes, that one's also closed, isn't it? That's a polygon. This one is not closed. Therefore, it can't be a polygon. Because polygons are simple and closed. So that one's not a polygon. Now, there's one thing I got to add to your sheet that I meant to put in there and I missed it. So underneath B, take your red, put an asterisk, and put the word convex. How many have heard that word before, convex? All right, I think it should have been in your curriculum either in 5th or 6th grade. All right, so something can be convex or it could be, say the owner if you know it, concave. So I'm going to give some room here and do concave. Polygons can be convex or concave. Anybody have a nice, easy way to keep them straight? Jordan? Not necessarily. They're both closed because they're both polygons. Anybody know an easy way to remember from the wording Which one is which? Andrew? The concave caves in. That's usually the way. You guys know what a cave in is? All right, unfortunately, you guys are the electronic generation. Have any of you guys ever gone out in a field, and dug a hole in the ground and got old boards and put them over top and built a fort? Have you ever done, any of you done that? Oh, wow, good, more than I thought. Yeah, we used to do it all the time growing up. Because I had a hill right behind my house, and we built forts all over the place. We'd take our shovels from our house, we'd dig them out, and sometimes they were pretty big, and we'd find pieces of board and old doors and whatever we could find and lay them over the top. And you know what happened when other neighborhood kids would come around and find our fort? They would cave it in. Those bums. Right? And we used to put dirt on top of our forts because you didn't want people to find it. So again, we would dig the dirt out, put the boards over top, put dirt on top of the boards. Well, you didn't want to be in it either and have a cave in, right? You know what a cave in is? Goes in. So cave in, concave is it caves in. So how about something like this? Here's a real simplistic concave polygon. Do you see the cave in part? There's a part that's caved in. It's like a dent. Right? Think of your car. Any of your cars have dents in them? The dent is concave, right? It's caved in. Henceforth into with concave would be the opposite of caved in, right? I don't know. Just something that doesn't cave in. Concave caves in. If you just remember, concave caves in, then convex does not. All right? Concave, convex. All right, what's next? We got to classify our polygons. Let's classify our polygons according to, this time, that should be black. You could do red if you want, doesn't matter. According to the number of sides. And you guys know a lot of these. Don't speak out loud until I ask you, but I will ask you on a lot of them. And everybody knows the name of the first one is a triangle. And that's boring. We know however, don't say anything on this one. A lot of people don't know the name of this very second one. By the way, you can't have a polygon with two sides. You know why? There's no way to close it. How can you, two sides, how can I close it, right? So there's no such thing as a two-sided polygon. The smallest number of sides is 3. It's triangle. All right, if you know 4 on 3, give me the answer. 1, 2, 3. I heard a few of them. It is a quadrilateral. Quadrilateral. L-A-T-E-R-A-L. Q-U-A-D-R-I-L-A-T-E-R-A-L. Quadrilateral. By the way, anybody ever ride a quad? Right? What do they call them, quads? Four-wheelers? ATVs? Quad means 4. I mean, that's what it means. It's a prefix for 4. And in my day, we called them quads. But not too many people had them back then. So, all right, so quadrilateral was 4. I think most of you guys know this next one because maybe some of your parents even work there. It is a pentagon, yes. And by the way, the pentagon looks like a pentagon. And it's a special kind of pentagon. We'll mention that in a minute. All right. What about 6 sides is a hexagon. Most of these you should know. You only need to work on the few that you don't know, right? All right. Who thinks they know 7? Don't say it. Who thinks they know? All right, I'll give you a shot on 3. 1, 2, 3. Heptagon. Hep. H-E-P. T-A-G-O-N. Heptagon. 7 sides is a heptagon. Yes, sir. Austin, he's going to help you out too. He's going to be a fine citizen. 12:30. That means you may have to take your stuff at the end of class, all right? That's what that meant. All right, eight-sided, we all know what is in. Octagon. That's why an octopus with 8 rays is called an octopus. Music. What happens when you go up an octave? You go up how many notes? 8 notes, yes. Amazing. Bet you didn't think I knew any music, did you? Not a whole lot. All right, number 9. Shh, don't say it. 9, not a lot of people know 9. Say it on 3. 1, 2, 3. Non-agon. Good, Connor. A non-agon. That's 9. Non-agon. Say 10 if you know it. No, decagon. You know that song, Deck of the Halls with Boughs of Holly? No, that's a different deca. All right. So deca is 10, deci 10, and that DEC really ties into 10. Anybody happen to know 12? Most people don't. 12? Jack? Dodecagon. Dodecagon. That's from Sound of Music, you know, doe, a deer, a female deer, ray, you know, All right, and then, believe it or not, end sides would be an engon. Yeah, I know, it's tough. Life is tough. Scurfy. That's what it is. However, whatever n is. If n's 20, it's a 20-sided polygon. If n is 100, it's got 100 sides. If n is 3, it's got 3. If n is 50, it's got 50. Whatever, it's a variable. No need to apologize. Here we go, number 2. Jack, question? Yeah, but Jack, there are some more special names like an isosagon, which I think is 20 if I'm remembering right. So there are a few more special names, but this course we only worry about up to 10 with the 12. So there are more, but you know, there's only so much you can keep in your brain. The rest you can Google or Bing or whatever. All right, number 2. It's important that you are able to recognize a regular polygon. A regular polygon. And it's important that you know the conditions that make up a regular polygon. And you can see 3 examples. There is a regular triangle, a regular quadrilateral, and a regular pentagon. And what makes them regular? All sides are congruent. So let me pause right there. Look at the screen here and understand this. Because, watch the triangle. Because this side has a 1 mark, let me go to my purple. And this side has a 1 mark, it means they're the same size, they're congruent. And that has a 1 mark, that means any side of that figure with a 1 mark are the exact same size. So all 3 of those sides are the same. Now when we get to our regular quadrilateral, and you can go ahead and do this, we're going to put a 1 mark on all of their sides because that is a regular quadrilateral. And we routinely call a regular quadrilateral a square. That's the common name, but understand this is a regular, and I'm just going to abbreviate quad for quadrilateral because that's a long name. So a square, but that's a regular quad. And by the way, let's go back. What do you call a regular triangle? Equilateral triangle. So again, a regular triangle implies equilateral. And again, I'm abbreviating for time's sake. Equilateral triangle. And by the way, if you look at the pentagon, you can notice that all 5 sides have the same marking, right? Meaning they're all congruent. But there's 2 parts to regular. All sides are congruent and all angles are congruent. Has to be both. And notice the angle markings of the equilateral triangle. Aren't they all marked the same, one marking? Notice the angles of the square. Each angle of the square is the same amount, 90 degrees. They're all congruent. And this pentagon, and by the way, we're going to learn how to figure out how many degrees each of those angles are. And we can do it mathematically. We'll get there tomorrow. Tomorrow. There's always tomorrow. I know we got to leave you in suspense. I know you're just dying to get the answer, but that's the way it goes. All right, so look, regular is a big deal because regular allows us to do some other things. So you got to know what a regular is. And by the way, every one that I showed the example of is a regular one. Each one of those are regular. The angles are the same amount and the sides are congruent. All these angles are congruent to each other, all sides. All this one's angle is congruent to this one's angles, and this one's sides to this one's sides. They're not all the same to each other within their own polygon, right? Within its own polygon, all angles are congruent and all sides are congruent, right? Look at your octagon. Usually you'll find them with the word stop written on them. Although that's kind of spun around a little bit, so. But anyhow, regular. You got to know what regular is. All sides are congruent. All angles are congruent. Well, we can also classify triangles by the relationships. You can underline that, of their sides. So first off, we said, hey, 4 sides, quadrilateral. That's just by the amount of sides. Now we're going to classify by the relationship of the sides. All right, I got to get rid of my screen so I can put this higher for you guys. All right, so let's classify according to the relationship. I'm not going to say what the name is. Don't say it if you know it. But what do we call a triangle is one with no congruent sides. So take your black, and I'm going to put a 1 marking on that side, and I'm going to put a 2 marking down there, and I'm going to put a 3 marking there. None of the markings match. Means none of the sides are the same size. Does that make sense? Anybody know what we call a triangle where no sides are the same length? John? It is not, but good try. It is not isosceles. Sam? It begins with the letter of your first name. Anybody? Ileana? It is a scalene triangle. S-C-A-L-E-N-E, scalene. That makes me think the rest of you heard that word before. And Ileana is the only one that remembers. Again, we can teach you stuff. You got to remember it. And that's the key in reviewing, is the key to remembering. All right, scalene. So you got to know that. Hey, you come up across a triangle. We're trying to name it in relationship to its sides. No sides are congruent. Scalene. Okay? I don't care how big it is. I don't care how small it is. If it's a triangle and none of the sides are congruent, scalene. All right, next one. Let's skip the name first. What's a triangle with at least 2 congruent sides? Don't say anything yet. Take your black, come down here and put 2 marks on one leg and 2 marks on the other. I don't know why I chose 2, but it doesn't matter. Usually it's only 1 on both sides, but it doesn't matter. Those 2 legs are congruent. And this triangle is called? Isosceles. I got the black. I-S-O-S-C-E-L-E-S. I-S-O-S. C-E-L-E-S. Isosceles. So an isosceles triangle is a triangle with 2 congruent legs. Whoa, he returned. Just like MacArthur. All right, just some terms here. The congruent sides are called legs. The non-legs is called the base. And here's an important relationship in isosceles triangles. You know what? the base angles are always congruent. And how can you tell the base angles? Go opposite the congruent legs. This angle, I'm going to put a 1 mark. It's congruent to this angle. I'm going to put a 1 mark. They're the same amount of degrees. Take your protractor and measure them. You find out that they're exactly the same number of degrees. Now in the second example to the right, the legs are here and here, right? Just because it's called the base, does that mean it has to be the bottom? No. It can spin any way your little heart desires. All right, let's see if I can capture it. No, not you. You. Come. No! That's what happens when you have a page behind it. Page wants to come. Oh, now I got my marks and everything. Brother. All right, let me just try to grab it. Oh, there we go, right? Does the base change if it spins? It doesn't matter. It doesn't matter if it's like this or like this or like that or like that or like that or like that. No matter how you spin it. Can I throw it? Okay, no matter how you spin it, it's still an isosceles triangle, and the legs are the legs and the bases are the bases. Okay, they are what they are. So where would the congruent angles be? Hopefully you agree this one and that one, right? The angles opposite the legs. The legs are the two congruent sides. We'll use that later on to figure out angles. For example, just real quick, let's suppose, I'll do it this way so those watching at home know. Let's suppose this angle, I don't know, we'll just make up, let's say it's 25 degrees. Don't do this, I'm just getting you think. If that one's 25, how much is that one? And therefore, then, how much is that? How much? 130, right? How much do the three angles of a triangle equal? 180. So see, we can get everything. We'll do that later. All right, let's go on to the next one. We already talked about this one. If you have at least 3 congruent sides, that's stupid. A triangle with, get rid of the at least. I never saw a triangle with more than 3 sides. So a triangle with 3 congruent sides, and we know that that is a equilateral. Equilateral. All right, not like football, we're not lateraling, but it is equilateral. And again, we're going to just 1 mark it. You can use black or red or green or whatever you want to show the congruent sides. Oh, by the way, because the sides are congruent, all the angles will also be congruent. Every excuse me, every equilateral triangle is also an equiangular triangle. Equilateral means the sides are congruent. Equiangular means the angles are congruent. It's one and the same. All right. A lot of classifying, huh? Got to keep all this stuff straight. Jordan.
For an equiangular triangle, does it all have to, all of the sides have to be equal at the angle?
So here's what Jordan just asked. Sounds like a homework question. True or false? Is every equilateral triangle equiangular, and is every equiangular triangle equilateral? True or false? True. If the 3 sides are congruent, then the 3 angles are congruent. If the 3 angles are congruent, the 3 sides are congruent. That would be a true statement. That would be true. That might be one of your homework questions. You'd never know. All right. We can also classify our triangles according to their angles. So a lot of classifying. You got to know what they're talking about. We talk about sides. We talk about angles. What are we talking about? We're talking about just all polygons. We're talking about triangles. What are we talking about? Okay. Let's start off with the cute one. She's a cute. She's in a cute triangle. Nice and slim and trim. Sorry, just is what it is. All right, she's a cute. And that is a triangle with how many acute angles? What do you think? Two? Three? One? There are only three angles, John. It's got to be three. It's got to be three. Look, if you say only two are acute, that means the other one has to be either a right angle, and is that now an acute triangle? No, that's a right triangle. Or the other one has to be obtuse, and is that now an acute triangle? No, that's an obtuse triangle. So all three. And that's the example there. Well, we know the second one. That is a right triangle, right? And that's a triangle with one right angle. A right triangle, we all know, a triangle with one right angle. No need to spend any time there. Oops, excuse me. And therefore, the last one is an example of an obtuse triangle. And that is one with one obtuse angle. Can you have two obtuse angles? No. You used up the 180. It wouldn't meet. It's impossible. Impossible. So acute, she's got three acute angles. She's really acute. Obtuse, one obtuse angle. Right triangle, one right angle. All right. Let's finish with this important aspect that we've already mentioned. But you, from now on, for the rest of your life, will make sure that you know, for every triangle, the sum of the measures of three angles is 180 degrees. You must know that. You must. All right. Let me show you the easiest way to make an equation, because I think your book asks you to make an equation. It says measure of angle 1, and angle 1 is right there. Do you agree? Let me show you the sides of angle 1 just to make sure you're understanding. It would be this side of the triangle and that side, right? Form angle 1. Do you agree? Is that clear with the red? Okay. So the easiest way is to say the measure of angle 1 will be the 180 degrees minus the other two. Minus 95 and minus 35. Does that make sense? Now look, everybody's got a calculator. Don't be missing a question like this. Don't miss it because you did the wrong number in your head. Right? It's fine if you want to do it in your head, but when you're done with your quiz or done with your test, take your calculator out and check it. Make sure you didn't make a stupid mistake, because it's a shame to lose points on stuff you know. So 180 minus 95 is 85. 85 minus 35 is 50. Anybody check me with their calculator? So 50 degrees must be angle 1. Uh-oh. What in the world? We only know one angle of the second triangle. Don't say anything. We're only told this one. We got to find 7. What are we going to do? What are we going to do? Anybody write an equation? Somebody tell me. I don't want the answer. I want an equation. I don't want the answer. Sometimes the answer is easier than the equation, isn't it? What's the equation? You can write it a couple different ways. Jordan?
And the measure of equals 7 equals 180
So far, so good. I'm with you.
divided by 2.
No, but that first part's correct. Measure of angle 7 equals 180. Need more. Raquel? I agree, but we're not there yet. Jean? No. Can't have a 0-degree angle. Adriana? Not necessarily. No. Nick? No. Kirsten? It doesn't look like a 90-degree angle to me, does it? What the, right? Ask the ma'ams on that. The ma'ams? Hey, the ma'ams, does that look like a 90-degree angle? No, so let's leave that one in the garage there. Josh? Minus what? N? Let's use something better than N, Josh. Let's use something better than N. Better than N. You got the right idea. You got the concept. Here's what Josh just did. He took this angle and called it N. And there's something better than N. Because right there with N, you have two things you don't know. You don't know 7 and you don't know N. Can you solve an equation when you don't know two things? And the answer is no. Not until you get to Algebra 1 and you have two equations with two things. That's a whole nother story. All right. What's better than N? Need something better than N. It's going to make you solve this, Andrew. There you go, right? Remember, we just learned that the base angles of an isosceles triangle are congruent, right? So there's another 7. Now, I'm not going to take a long time on the equation, but would you agree? Let's get all our variables on one side. Let's add a positive measure of angle 7 to both sides. Does that kind of make sense? Equation? Right? Things, you add their opposite? What's one measure of angle 7 and another measure of angle 7? One of them and one more of them is? Two of them. You now have two measure of angle 7. Would you agree? Nothing hard there, right? Again, when we're done, I'll show you an easier way to fool with it. But this would be the mathematical way. And what's 180 minus 25? 155? 155. Oh, now wait a minute, folks. We'd have no earthly idea how to move that 2, would we? We'd just have no clue. We would have no idea how to solve this. We wouldn't know how to finish, because we've never done angles. I mean, we haven't learned any principles that we could apply here or anything like that. So we'd say, I'm stuck. I'm stuck. You know, if you're stuck all the time, let you in on a clue, you don't really get anywhere. You know, in real life, if you're in your car and you get stuck, you know what you better do? You better get out and get unstuck, okay? Come on, well, how would you finish this? Just say it. Divide both sides by 2, right? We know what to do. So punch in your calculator. What do you get? What in the world is that? 77.5? That's how much each one of them is. 77.5. Right? These two are the same. So these two together and that one have to be 180. Good job. All right. You say, I'd have never thought of that in a million years. Okay, I understand. That's why I gave you the example, okay? That's why I showed it to you. So that now you're thinking that way. Adriana, don't pack up, please. Go ahead. No, leave it. Because they're exactly the same, leave it. Because they got to add up to 180. That one we got to leave. And sometimes it'll be like 20 and 20 or 60 and 60 or 80 and 80. If the only other possibility is a 0.5. It's either exact or a 0.5. It's either a whole number or 0.5, and so leave it. Leave it. Because they have to add up to 180. All right, I did half the lesson, just like I did earlier when we were doing lesson 0.2. So I'm trying not to overload you. But even in that, we still got to do page 505, 1 to 21. It's a lot of just naming stuff. It really shouldn't take you long. There's only a few things like these last couple problems. But listen, you got to start learning these names, and you got to start learning how to classify, okay? So, and by the way, how many of you guys are going to keep losing credit because you're not going to write the originals? Why are you being so silly? Just throwing points away. I think I'll just throw points away because I'm too lazy. Hey, Mom, I really can't get this math. I really didn't get a good grade. Oh, but Mom, it's only because I'm lazy. Come on. You're smarter than that. I hope.